continuing our factoring journey by factoring trinomials. Now, a trinomial is an expression with three terms. So, in this case, our form is ax squared plus bx plus c, where a, b, and c are constants. So, when a is 1, meaning my coefficient on x squared is just 1, these are a little bit easier to solve because what we're looking for are just factors of c, our last term, that combine to make b, the coefficient of our middle term. So when c is positive, we're looking for factors of c that add to b, and if c is negative, we're looking for factors that subtract to b. So here are some examples. Here my coefficient on x squared is just 1, so I'm going to look at my last term c, and I'm looking for factors of 6 that add to b, which is 5. So I'm going to be using my double parentheses here, and the factors of 6 that add to 5 are 2 and 3. My coefficient on x was just 1, so that's going to be x, and everything is positive. So when I factor that, I'm going to get x plus 2 times x plus 3. Okay. On example B, my c term is negative 6, so I'm looking for factors of negative 6 that subtract to my middle term, which is 5. So factors of negative 6 that add to 5 are going to be positive 6 and negative 1. Okay. Then on C, factors of negative 6 that add to positive 1, that is going to be negative 2 and positive 3. Okay. Now on D, I have 3 terms here, but I want to take out a greatest common factor first. So between 3, 9, and negative 12, my greatest common factor there is a 3. I don't have an x in this last term, so I cannot factor out an x, but I do have a y to the first power in each of those 3 terms, so I can take that out as well. So I'm going to be left with x squared plus 9x, excuse me, not 9x, that would be 3x minus 4. So now I'm looking for, I've got a trinomial inside of here, so I'm going to be looking for factors of negative 4 that add to 3. So that is going to be positive 4 and minus 1. So there is my final completely factored answer for example D. Looking at E, again, I want to take out a GCF. So between 2, 26, and 84, I can take out a 2. And then b to the 4th, b cubed, b squared, I can take out a b squared. And that's going to leave me with b squared minus 13b plus 42. And that is a trinomial, so that 2b squared I took out stays in the front. And I'm looking for factors of positive 42 that add to negative 13. Now recall, a negative times a negative is a positive, but when you add them, they stay negative. So this is going to be 2 negative numbers, and 6 times 7 are factors of 42 that would add to negative 13. So negative 6, negative 7. And there is my final factored answer. Okay. All right, so that was when our coefficient on this x squared term is 1. So when a, that factor, is greater than 1, there's a couple different ways that we can factor. And if you're familiar with another way, you're welcome to use that. But this is one of the ways that we can factor. And this is called splitting the middle term. So remember, that's our a, b, c. So the first step is to multiply a and c. So in this case, that's 3 times 10, which is going to be 30. Then I'm going to look for factors of 30 that add to my middle term b, 11. And that would be 5 and 6. So I'm going to rewrite my expression having separated that middle term back into 5x and 6x. So I've got 3x squared plus 5x plus 6x plus 10. So I split that middle term 11x back into what we had combined our like terms with when we FOILed. So now I'm going to factor by grouping. So these first 2 terms, my GCF is x, so that leaves me with 3x plus 5. And here, my GCF between 6x and 10 is 2, and that leaves me with 3x plus 5. So 3x plus 5 is a common factor, so I can pull that out. And that leaves me with x on the first term and 2 on the second term. So there is my final factored answer. And then the nice thing about factoring trinomials is that you can check your work by foiling what you end up with. So if I FOIL this, I get 3x squared plus 5x plus 6x plus 10. And I should end up with what I factored. And if I do, then that means that I have factored correctly. All right, let's practice this a little bit more. On F, again, I'm going to multiply my A and my B terms. And I'm just going to organize it in this little X to make it more clear. So 5 times 9 is 45, and my middle term is 18. So I'm looking for factors of 45 that add to 18. Well, that would be 15 and 3. So when I rewrite this, 5x squared plus 15x plus 3x plus 9, I'm going to factor by grouping. So I can pull out a 5x, I can pull out a 3, and so x plus 3 is the common factor. So it leaves me with 5x on the first term and 3 on the second term. Okay. On G, I've got 5 times negative 12, so that's going to be negative 60, and my middle term is positive 11. So I'm looking for factors of negative 60 that will subtract to 11, and that's going to be positive 15 and negative 4. So 5x squared plus 15x minus 4x minus 12, grouping, and then I've got x plus 3 as a common factor here, and that's going to leave me with 5x minus 4. Okay. 4 times negative 21 is going to give me negative 84, and 5 is our middle term, so I'm looking for factors of negative 84 that add to 5, and so that's going to be positive 12 and negative 7. Grouping, and then x plus 3 seems to be a very popular common factor here. And there's factored h completely. Okay, then I, 9 times 10, 90. So it multiplies to a positive number and adds to a negative. That means that these are both going to be negative. And so that's going to be negative 45 and negative 2. So 9x squared minus 45. Oops, that should be 45x, not just 4x. Got a little too excited there. GCF. So I'm going to get x plus 5 times 9x minus 2. Then on J, between 2x cubed and 18x, I can factor out a 2x, and that's going to leave me with x squared minus 9. Now, recall from the first day that we factored polynomials, this is a difference of squares. So that's going to be x minus 3 times x plus 3. And again, any of these we can double check by foiling. Now, perfect square trinomials, this is when, if I were to factor this, my coefficient here on A is just 1, so I'm just looking at factors of 9 that add to 6. Well, that's 3 and 3. So this is x plus 3 times x plus 3, which is just x plus 3 squared. So when I have a perfect square trinomial, my FOILed trinomial is going to be x, whatever my first term squared is, plus 2 times a and b plus b squared. So here, my a term would be 5x, and my b term would be negative 4. Because if you look in the middle, this is 2 times negative 4 times 5x. So 5x minus 4 times 5x minus 4 would be the correct way to factor this one. So 5x minus 4 squared. A little more practice with factoring. On this one, I have a GCF here of x squared, so I'm going to factor that out. And I have a GCF here of -4, so if I factor that out, I've got a common factor of x minus 3, and that leaves me with x squared minus 4. Well, x squared minus 4 is a difference of squares, so I can factor this further, x minus 2, x plus 2. And there's my final answer. Okay. Then on n, if I look here, this is a perfect square trinomial, so that's actually x plus 3 squared. That's just like example K that we just worked. So x plus 3 squared minus y squared, that's actually difference of squares. Here, your a is x plus 3 and your b is y. So x plus 3 minus y times x plus 3 plus y. Looking at O, this is a perfect square. This is actually a minus b squared, minus 16. This is, again, difference of squares. So here a is a minus b, and b is 4. So a minus b times a plus b. And I have an extra parentheses on this one. That parentheses doesn't need to be there. Okay. Now this one, we notice here that this is a trinomial, and I've got 3 negatives here. I can factor out a -1 and make all of this positive. And this is actually now a perfect square trinomial, where the first term is a, and we're going to get 5b as our second term. So this is, again, a difference of squares, where now a is actually 6 and b is a plus 5b. So a minus b times a plus b. So there's the final answer on P, final on O, and that was our final answer on